So, okay, today we're going to study trigonometric functions and derivatives. I begin with a following limit because we needed that to find the derivatives. The formula says that the limit of theta approaches 0, sine theta over theta should be equal 1. Okay. We proved that before, using the inequalities we have. Okay. So I'm not going to repeat that. I'm going to use this to find the limits of other type of function. For example, what is the limit of x approaches 0, sine 3x over 5x? Okay. How do you solve this problem? Well, you can express this in the form sine, let's put a theta here, use a substitution, right? Theta equals 3x. Right? When x approaches 0, theta approaches 0. So it's a 5. What is x? Theta over 3. So after you simplify, you get 3 over 5 and the sine theta over theta. Okay? So we do not just take it. You cannot take 3 out of sine 3x. But you can express it in that form, 3 over 5. So the limit as theta approaches 0, because x approaches 0, right? So theta approaches 0, then this will be 3 over 5 times 1. That's why it's going to be 3 over 5. Okay? Now, if you write in this form, then that's wrong, okay? I cannot give you credit. Because mathematics, this is very fundamental mistake. It's what we call a serious mistake. Not like, oops, I make a stupid mistake. It's not stupid. Why? Because sine 3x is not going to be 3 sine x. This is a conception, okay? There are some serious mistakes. There are some just small mistakes. When you copy the, if you copy the function 2x and forgot 2, that's a small mistake. Okay. So now the next one. As theta approaches 0, sine theta square over theta. How to find the limit of this? Well, sine theta over 3, right? You can modify like this: sine theta square, and multiply theta. And when theta approaches 0, theta square approaches 0, right? So theta square, sine theta square over theta square, this is the same, So that's why this approaches 1 times the theta approaches 0. So that's why the result is 0. Theta approaches 0. Okay, because this limit is 1. Okay, so the answer is 0. Yeah, sometimes you can use substitute. Sometimes you say, okay, I'm fine with this. You just use a theta square. That's okay. Next one is as x approaches 1, sine x minus 1 and x squared plus x minus 2. This one, you see that when you plug 1 for x into the denominator, it is going to be 0. So sine x minus 1 over x squared plus x minus 2 is going to be sine x minus 1, and here x minus 1 and x plus 2. So x minus 1, x minus 1, if it's better to use a substitution, let's theta to be x minus 1. Okay? If theta equals x minus 1, you get sine theta over theta. And what is x plus 2? X is going to be theta plus 1, right? So x plus 2 will be theta plus 3. Yeah. Okay? So you will get 1 over theta plus 3, and here sine theta over theta. So as x approaches 1, theta approaches 0. Okay? So when theta approaches 0, x approaches 1, that's the same. Then this is going to be 0 plus 3, and here is going to be 1. So the answer is 1/3. So the limit is 1/3. Okay. Yeah, let's do more exercise. Limit as x approaches pi over 4, 1 minus tangent x, and here sine x minus cosine x. Okay, we know that sine pi over 4 equals cosine pi over 4 equals square root 2 over 2. And the tangent pi over 4 equals 1. So when you plug pi over 4 for x into the denominator and into the numerator, you get 0 over 0. So you cannot say it's a limited and defined, you know, okay? Just because you're not able to find it. You have the limit is not a variable function. The limit is a procedure, you know, process as x approaches pi over 2. What is the limit of the function? Okay, even the limited case is 0 over 0 type, but still the denominator you don't have a limit. So you have to modify this. Okay, you have to modify this. So the question is, how do you solve this problem? Okay. If you don't like, you know, I'm familiar with a cosine x, sine x. So what I'm going to do is I change tangent x to sine x cosine x, so, right? So I'm simplifying this first. So I'll get, this will be cosine x minus sine x, and sine x minus, this is a cosine x here, cosine x. So let's simplify it further. So I get cosine x minus sine x, and sine x minus cosine x, and here cosine x, right? Then you will see the numerator denominator that's different by sine. So it's going to be negative 1 over cosine x. This is very simple. All right. After you simplify it, then it's easy to see the limit. Okay. So the limit is going to be cosine pi over 4 is square root 2 over 2. So after you simplify, you get square root 2. Okay. So this is the answer. So the limit is negative pi over 2. Yeah, this is I have to put a note here, okay? Pi over 4, because they're not equal, just approaches that number. Right, our next problem is to find limit theta approaches 0, 1 minus cosine theta over sine square theta. This has a limit. Okay, can you simplify? There are many ways to solve the problem. I think for the easiest one will be will be 1 minus cosine theta, and that times 1 plus cosine theta. And then this is sine square theta, 1 plus cosine theta. Then numerator is 1 minus cosine square theta, right? And which is sine theta, sine square theta, okay? So you will cancel out the numerator and denominator. Actually, you only get 1 over 1 plus cosine theta, okay? Just to cancel it out. Yeah. Okay, because it's going to be sine square theta. This is equal to sine square theta, so sine square. Then it's clear that when theta approaches 0, it's 1 plus cosine 0, which is 1 over 2, right? So this is the limit. Okay, as theta approaches 0. If you plug 0 for theta in the original equation, you get 0 over 0. So you cannot determine the limit. Does not mean the limit doesn't exist, just because we cannot determine the limit in this way. Right. Is there any other way you can do it? Still, yes, there are multiple ways. Yes.
It's like a conceptual question. Why, like I understand algebraically how it works and how it works, but why would it work since it's supposed to be like equivalent to each other? Working through the algebra isn't changing the problem itself.
Well, I just changed the function. The function can be simplified, okay, using, because sine theta, cosine theta are internally related. Because they look different. They're not essential. Sometimes they're similar. They're not essentially different. Okay, like the cosine square theta plus sine square theta equals 1 theta. So sine theta, cosine theta are related. So the original expression, it's harder to read it, right? To figure it out. So you rewrite the equation. You write the expression. You simplify it to this. Just okay. So we see we simplify this to when they are equal. Just change the form, okay, of the expression to that. Then you can, this holds when theta are not equal to 0, okay? This holds, it's very similar to like a x squared over this. This is going to be x plus 1, but when x is not equal to 1, okay? It's very similar to that. But if you plug 1 for x, you get 0 over 0, okay? You do the cancel some term. And similarly, we have this here, okay? Then after you modify, we don't say simplify, sometimes you don't get simpler form. After you modify the expression, then you can see, you can easily find the limit as theta approaches 0. Right? That's another way to modify. It's not unique, okay? It's not unique. So 1 minus cosine theta over sine square theta. 1 minus cosine theta. I want to get rid of 1, right? And that is going to be 1 minus 2 sine square half of theta. It's called the half angle formula. So after you simplify, you get 2 sine square half of theta and sine square theta. Okay? And then that's another form. It's not unique. It's not necessary to be 1 over 1 plus cosine theta. If you take 2 out, and then you get sine half of theta and sine theta squared. Right? So that's okay, but we can easily find the limit of this. Okay. Why? How do you find the limit of this? Well, you divide the numerator and denominator both by theta. Okay, so you get sine half of theta over theta, sine theta over theta. All right? Then you know the limit of each term. And theta approaches 0, the numerator is going to be 1/2. The denominator is 1. And the square. Okay? And then it's going to be 1 over 2. So you see the same result. Okay? Why? Because we already know sine A theta over B theta, as theta approaches 0, this approaches A over B. Okay? We're using this fact. Okay. Okay, so for the same problem, there are several ways to solve it. And we use the different formulas in trigonometric geometry. Okay. So even if you forgot this formula from in trigonometric geometry, but this is the time, this section, you're going to review these formulas and you will understand and use them. Okay. There are other formulas. Let me mention that. We have sine alpha plus beta equals sine alpha cosine beta plus cosine alpha sine beta. Yeah, this is an important formula. Okay, but if you put a negative sign, and there was a negative sign here. Okay, and how about cosine alpha plus beta? It'd be cosine alpha cosine beta. But when it's plus, it must be minus. When it's minus, it must be plus. Okay. I'm not sure you still remember this formula. That's what's they're needed. Okay. So those are the formulas we should know. Okay. Okay, you can double check. You see, the first formula, you can let beta to be alpha. In the first formula, if you choose positive sign, then what do you get? You get sine 2 alpha. Then you get sine alpha plus cosine cosine alpha. Yeah, cosine alpha, sine alpha. So it's twice sine alpha cosine alpha. Okay, so this is a formula we're familiar with, right? This is in equation 1. If you also let beta to be alpha and choose the positive sign in equation 2, what do you get? You get cosine 2 alpha, right? Because alpha plus alpha. That would be cosine alpha and cosine alpha, so square, minus sine alpha times sine alpha. So you get another formula we're familiar with. So those are the two special formulas from the above two formulas. Okay? One is called double angle formula. They are called double angle. All right, so let's do the following exercise. Find the derivative of the sine theta. Okay? Find derivative of sine theta using the limited definition. Because we don't have any formula here, right? We know the derivative of the power function is going to be x to the k times x to the k minus 1. But this is the second one we want to know. Okay, we are very curious about that. What is the derivative of sine theta? Okay, we are now given. Suppose, yeah, you don't have any textbooks in the world, and you already learned the concept of the derivatives using limit, right? And you started to write a book for that. Okay. Yeah, some of the books in history, some mathematicians just write a book before publishing anything, and then surprised, oh, that's huge. You know, how can you know that, right? There do have some genius people there, I have to admit. I went to IPR library, I looked at all the books, I found the one's called Collection of Newton's Work. And I pulled out one volume, I look at that, and I have to say that Newton was the expert in the trigonometric geometry, because the whole volume is about sine, cosine, theta. And he's just playing with that. And he applied them to understand the universe, okay? At least the solar system. And he was not to that level like Albert Einstein, but at least he could describe the orbits of the planets, okay? But he has to use this sine, cosine, those kind of periodic functions. But at the end, he couldn't understand the word realities, and he trusted in God. Okay? It's not trying to figure it out by himself, and he couldn't. Right, so this is a derivative of sine theta. You see, be careful. I put the x in, then be careful. This should be theta. Okay, same variable. So by definition, the derivative of sine theta with respect to theta is going to be the limit as h approaches 0, and here's h. Sine theta plus h minus sine theta. Okay, I want to find this limit. I know if you plug 0 for h, I get 0 over 0. Okay, the numerator becomes 0, denominator becomes 0. So it's not easy to see the limit. So I have to modify this. For the simplicity, I'm not going to keep writing limit as h approaches 0. So I'm going to modify that. How can I modify this? I have sine theta plus h and minus sine theta. The only formula I can think about is the sum, right? Right? So it's going to be sine theta cosine h plus cosine theta sine h and the minus sine theta. Then what? Well, I can group them together. I can group this together, right? So I get sine theta. Then have a cosine h minus 1 over h. And the second part is cosine theta, sine h of h. All right, not too bad. My claim is I will need to know what is that limit. This approaches 0. This approaches 1. Why this approaches 0? Sine h over h approaches 1. We know that, right? Why cosine h minus 1 over h approaches 0? As h approaches 0. Right? And let me accept this fact. It's going to be sine theta times 0, cosine theta times 1. So the answer is cosine theta. Right? Why cosine h minus 1 approaches this approaches 0. The reason is very simple. How do you do that? There are a couple ways. You can use a double angle, half angle formula. You can also multiply this by cosine h plus 1 and h cosine h plus 1, okay? The reason is I want to get the cosine square. I get cosine square h, sorry, it's not a hyperbolic cosine. This is a cosine square h minus 1, h. Okay. But cosine square minus 1 becomes sine square. It's negative sine square h, okay, over h. Okay. Okay. I have to put sine square h. I have to put h square here, then h. Okay. Clearly, the first part approaches 1, but the second part approaches 0 over 1 plus 1. So it's 0. Okay. Cosine h minus 1 over h approaches 0, okay? As h approaches. So we verify this certainty. All right, so my answer here is the derivative of sine theta equals cosine theta. Okay, so this is the first formula. The second formula, the derivative of cosine theta equals negative sine theta. Okay, by same argument, I'm not going to repeat it. So I'll give you these two formulas. Yeah, you have to buy the same argument to get the limit derivative of cosine theta. Okay. Now, then you can use those two formulas to find the derivative of tangent theta. you don't need to use the same limit argument to find the derivative, okay, of tangent theta. Okay, here you still have to use, you have to still use you use the limit to find the derivative. Okay, so you by this argument you can show that, and that's good exercise. Okay, but I'm not. But how about the derivative of tangent theta? If you want to find the derivative of tangent theta, you don't need to use a limit definition. What you have to do is just use the quotient rule, okay? Because tangent theta is not a new function. Just for some reason, we want to give a new name, but essentially it's just sine theta over cosine theta. It's not a brand new function, okay? So it's going to be the derivative of sine theta cosine theta. Even sine theta and cosine theta are not complete independent function. Sine square theta plus cosine square theta is going to be 1. So these two functions are related. One can determine another. It's differed by positive and negative sign. Okay. So in trigonometric geometry, only one function essentially is just sine theta. Right? Because cosine theta is going to be plus minus square root of 1 minus sine square theta. Okay. Tangent theta is sine theta over cosine theta. Cotangent theta is cosine theta over sine theta. Okay. But why we have to name so many different functions? Because it's convenient to express something, give a couple more names. Right? All right, by the quotient rule, it's cosine square theta. Okay, and the derivative of sine theta, cosine theta, minus the derivative of sine theta as a derivative. Okay, so those sine function, cosine function are not created by mathematicians. Okay, they are there. Okay, we just name them. Okay, we find the sine cosines. Okay, or you can say it's already there. It's given created by the God. It's okay, but we do not. We just discover it. Okay, we don't make it. Okay. So scientists can only discover things. Engineering make things. Okay, so that's smart. There's a difference. Okay, you have to make new stuff. Create. Okay. So the derivative of sine theta is going to be cosine theta. The derivative of cosine theta is negative sine theta. So my son, he wants to be engineer. My daughter, she says she wants to become a scientist. I encourage them, study hard. But I ask them, what's the difference, because there's engineer or scientist, right? I have to ask them to figure out the difference. Okay. All right, so let's simplify it. And the cosine square theta plus sine square theta is 1. So it's 1 over cosine square theta. Now you don't need to name a new function. Maybe on some planet over there, we could still call them human being, right? They have some math book, but you don't see secant x or cosecant x because that's necessary. Okay, but here we have to name it. The 1 over cosine is secant theta, and we give a new name for the 1 over cosine theta. Right? It's not necessary. Okay, yeah, that's my opinion. Okay, but since we already have a name there, we just call it secant theta, 1 over cosine. Okay. So let's find the derivative of secant theta. How about this? The derivative of secant theta, it's going to be, right? We don't know the formula. I cannot remember, right? Maybe I still remember. But let me find out. Secant theta, it's not a brand new function. I only memorize the formula for the derivative sine theta, cosine theta, right? So what I'm going to do is I express as this form, right? Then it's quotient, but this is very nice quotient. The numerator is just 1. Okay, so it's going to be cosine square theta, and the derivative of 1 times cosine theta minus 1 times the derivative of cosine theta. Okay, what I get is going to be negative the derivative. It's giving me sine theta, right? So now what? Okay, so you can say this is a derivative, fine. Okay, but you can also write in this form. Okay, then what? The first term is called tangent theta, the second term is secant theta. That's okay. So in some textbook, there's a formula given that the derivative secant theta is given tangent theta times secant theta. Okay, and you should know. If you forget the formula, you make sure just find it by yourself. Right? You don't need to search for the formula, because when if you spend like 1 minute to find the formula in the textbook, you probably can find it by yourself. Only spend a few seconds. Okay, that's better, If just use that. If you know secant theta is 1 over cosine theta, just find the derivative using a quotient. Okay, then you get the formula. Right, by yourself. There are some interesting phenomena you will see. I assume y equals sine x 1 minus cosine x. I want to find out the derivative y with respect to x. Okay, this function, there are many forms of this function. You see, whenever you see 1 minus cosine x, I can multiply it by 1 plus cosine x, right? What is the purpose of doing that? Because I want to get 1 minus cosine square x, right? Then the denominator will be just sine square x. And after you simplify it, you get another form. It's interesting. You see, sine x over 1 minus cosine x equals 1 plus cosine x divided by sine x. Just turn upside down, but of course you change the sign. Right? So those two functions, no, just only one function. That's one function, but in two different forms. So then how do you find the derivative? You can use any of the form, okay? We haven't simplified the expression. We still get a similar form. Complexity is the same, right? Just turn this upside down. So I'm going to use a derivative, use a quotient to find the derivative. Okay, and here sine x prime, 1 minus cosine x minus sine x times 1 minus cosine, right? Let's see. I was trying to simplify the expression, but I couldn't. I'd get a similar one. I haven't, yeah. The complexity is similar. All right, so let's still go back to the original function. All right, so derivative of sine x is going to be cosine x And here sine x. So derivative 1, 0, the derivative negative cosine x is going to be sine x. Yeah. Okay. So now what? I have cosine x minus cosine square x minus sine square x. So what is the next step? Well, cosine square, sine square should be equal 1. Add them together. So right? So now you can simplify a little bit. Cosine x minus 1. Okay. They are different by sign. 1 minus cosine x, 1 minus cosine x. This will be negative 1 minus cosine x. Okay. So what does that mean? We find the derivative, and that is going to be equal to negative 1 minus cosine x. Huh. See, we just drop the negative, the numerator, change the sine x to the negative 1. Right? That's weird. Right? That's what we got. Since I think we have make any computation mistakes, we believe this is the correct answer. Okay. We apply the quotient rule to solve the problem. Right? And if you differentiate, I'm gonna ask you to differentiate this 1 plus cosine x over sine x. Yeah, reduce the problem. Okay, please find the root of this. All right, so I just wanted to repeat the procedure to get it, okay? I know this is the same function as the one I already gave to you, right? We simplify it. Suppose you did not know that part. What is the next step, right? Apply the quotient. Okay, 1 plus cosine x part and minus 1 plus cosine x sine x part. Okay, let's simplify it. That's going to be negative sine x and that's going to be cosine x. Right, be careful, we're going to simplify it. We get negative sine square x minus cosine x minus cosine square x. Okay, I find out this is just negative 1 minus cosine x over sine square x. So if you take a negative sign out, well, I just multiply the denominator by negative sine x. Right? Compare with the original expression. The numerator is still 1 plus cosine x. It remains unchanged. It's pretty strange. Okay. All right, so next problem is we have tangent x minus 1 over secant x, and you find the derivative. Okay, we know bunch of formula, right? We know the derivative of tangent x, and that will be secant square x. We know the derivative of secant x, that will be tangent x times secant x. But should we use that or not? It's a question. My suggestion is to simplify the expression. Okay, how do you simplify? It's already simplified, right? Tangent x, secant. I'm afraid of like tangent secant. It's too many things I have to memorize. I just memorize sine, cosine stuff. Only left to the formulas. How about that? Okay. Assuming your biological memory is not like super great, okay? You cannot store all the data. So you just look at sine, cosine. So let's look at the sine x over cosine x minus 1, right? And the secant x is 1 minus cosine x. Then you will see that sine x over cosine x minus 1 times cosine x. Okay, then you multiply them out. You know what? You get the sum of these two functions. That's simple. Okay, I'm so friendly, right? I know what is derivative of sine x, what is derivative of cosine x. So the derivative of this is going to be cosine x. The derivative, the negative cosine x is going to be sine x. That. But if you want to use a quotient rule to find a derivative, you still have to simplify. Maybe this is a tangent x minus 1, right? And I'm going to suppose to differentiate using without changing the function. Okay, what I'm going to do? I'm going to get secant x squared, and then the derivative of tangent. I think tangent minus 1 is gone, right? Secant x minus tangent x minus 1, secant x prime. And then you will see, oh, it is not easy. Okay, this is secant square x, secant x, tangent x minus 1, and that will be tangent x times secant x. What? You see, this is so complicated. Okay? And I'm not sure I can simplify it quickly. Okay. But it's going to be cosine x plus sine x. But you don't see that at this point. Okay? But at least you have a secant x in every term. Maybe you can cancel one secant x and cancel that. That's okay. So I get secant square x minus tangent square x plus tangent x and secant x. Secant x plus minus tangent x, are we able to simplify? We know that tangent x plus 1 equals secant x. So you can replace, if you don't like secant square, then just replace by tangent x, right? So tangent square x plus 1 minus tangent square x plus tangent x. And then you get the 1 plus tangent x secant x. That's it. So this is simple form. Okay, we begin with what? We begin with tangent x minus 1 over secant x. So we find out the derivative of tangent x minus 1 over secant x is going to be this. It's okay. It's in a similar form. So I'm satisfied with this signs. But if you really want to change it to sine cosine, it's just sine x plus cosine x. Okay. But it takes, you see, it's more complicated to find the derivative without simplifying the function. Okay? So you do your best to simplify function. Our next problem is applications. Okay? For what values of x does the graph of f, okay, have a horizontal tangent line? Okay, so my function f of x is going to be x plus 2 sine x. It looks like this is a graph. Okay, I think y equals sine x is a y equals x is a straight line. Then sine x just disturb y equals x. Okay, so when x equals pi, sine x is here. When x equals 0, it's here. So it's going to be, when it's 2 pi, right? So my opinion is going to be like that. Okay, it's going up, down, up, down. Okay, even go up a little bit. It's not like straightforward. Okay, it could be like this. Let me draw the picture. It could be like that. Okay. Okay. Why? Because in like in physics, this is a main term. This is what we call the noisy, right? Up, down, right? This is Otherwise, y equals x is a straight line. But sine x does not change it too much. Between negative and positive, because kind of noisy, right? Able to modify the function. So, but if you look at the whole graph globally, you will see that going up, right? But it's nearby the line y equals x. Okay. So does it have a horizontal line? I think so. If you draw the graph correctly, you do have a horizontal line. And between 0 and 2 pi, you have two horizontal lines. and then periodically. Yeah, it's not periodic function, but I think the pattern is periodical. Okay, so you should have a pair of horizontal lines in the next interval from 0 to 2 pi, then from 2 pi to 4 pi, right? Okay. So how can I solve the problem? Well, slope, yeah, let's call it A, right? At this particular point, A and f of A, right? The slope at point A and f of A is going to be the derivative of the function. Right? You have to write down this clearly so we know what's going on here. Then you find the derivative. It's so easy, right? Its derivative is going to be just 1 plus 2 cosine A. Okay, you differentiate with respect to fx. Okay, so this is a slope. This its tangent is horizontal if and only if the slope is 0, right? Yeah, slope is 0, the line is horizontal. Then the question is, how do you solve this equation? Or cosine A equals -1/2. Can you list all the solutions for A? How do you solve an equation like that? This is the math 159, topic 154, trigonometric geometry. Okay. You can use a picture. You can see you should have two solutions in from interval from 1 to, look at this is a graph only for cosine, right? It's a periodic function, right? So here's 2 pi. -1/2 is here. So you should get two solutions, A1 and A2. If you're able to find A1 and 2, you can get all of them because the first one is going to be A1 plus 2k pi, it's a sequence. And another solution is going to be A2 plus 2k pi. Okay? It's a periodic function. But you have to find the two solutions within the interval from 0 to 2 pi. Okay? You can, I guess, and try. I know cosine A equals 1/2. If A is small angle, it's being cosine 60 degrees. Okay? So you should know something about this. 60 degrees is going to be 1/2. Yeah. And the sine 60 degree will be square 3/2. Cosine 60 degree is pi 1, but I have a negative pi 1. Negative pi 1. Negative 1/2, right? I think if I draw it correctly, I think I can solve the problem. Look at this. So that's a 60 degree, right? Okay. So by the symmetry, okay, this point is pi. 60 degrees is going to be 60 degrees equivalent to pi over 3. Okay. So I think these two pieces are same. Okay, and I know this is going to be pi over 2. That's a pi. That's a pi, 3 pi over 2. Right? Pi over 2. So this is a pi, right? So this piece is the same. So two solutions. A1 should be pi minus pi over 3. Right? It's going to be 2 pi over 3. Another one is going to be pi plus pi over 3. You know what? It's going to be 4 pi over 3. Okay, you get two solutions. The reason is, so this is a pi. The reason is from here to here, it's pi over 3. Okay? And I think from here to here also pi over 3. So that's a pi minus pi over 3, you get that angle. Okay? And the pi plus pi over 3, you get the A2. Okay. So we get those two solutions. Yeah, but I'll show you another way. Geometry picture, if you don't think it's helpful, then you can solve this. All right, so you are looking for cosine A equals negative pi over 2. Okay, you're looking for the solution in the interval from 0 to 2 pi, right? You want to find out all the solutions. Okay, how do you do that? Okay. We have the references angle. Okay, references angle is always between pi over 2 and 0. Okay, and every angle there's a references angle. If this is A, then you have A over that, right? The key point is cosine of the references angle is going to be absolute over A, which is going to be negative 1/2, which is 1/2. But the references angle is between 0 and pi over 2. So it's going to be pi over 3. And that's a references angle. And the cosine A is negative means for cosine, this is a positive, y equals A, right? Cosine A. And this will be, cosine will be negative, negative positive. So the angle must be here or there if this is a references angle, and this is A, okay? And plus minus pi, you get the solution. That's why A equals pi plus minus the references angle. Okay, so it's pi plus minus pi over 3. Okay, so that's a references angle. You have two angles. So you get the same result. And finally, I want to find out the following derivative. Find the derivative of sin theta over 7. Yeah, it's a little bit confused, right? Sin theta over cosine. That's sin theta over theta. If the answer is 1, then it's wrong. I'm asking you to find the derivative. Now I'm asking you to find the limit. Okay. So this is nothing to do with the limit. I know the limit of sin theta over theta is going to be 1. But we're not going to use that. Okay? It's nothing to do with the question. Clear? Okay. The question is, what is the derivative of that function? That's a quotient of two functions. So it's going to be theta squared and sin theta and times theta minus sin theta and theta prime. So very simple. It's going to be cosine theta times theta minus sin theta over theta squared. Can we simplify it? I don't think so. Okay. So this is the answer. Okay. I put this one on the previous test. I find out maybe not 1/3 is maybe 25% of students put the answer 1. They start to find a limit for some reason. Did not read the question carefully, so they have to read the question carefully. Okay, I'm asking to find the derivative, not the limit. Okay, you have to read the question carefully. Okay, and there was a interesting story. Is I gave a quiz, and Winston came to my office to take the makeup quiz. Okay, and for some reason he already got the copy of the quiz, so he thought I'm going to give the same quiz, right? So actually the problem is already modified, and he just sit there, even did not read the question. He just write down the solutions to the original quiz. Then he called me and said, "How do you know the original quiz? Right? You supposed shouldn't to ask for the copy of the original quiz." So read the question carefully. He was not even reading it, just write down the answer. Okay, it's totally different problem. Yes. Okay. I think that's all about all the problems I discussed today. Maybe I'll just do one more problem, then we finish. Okay. Let's do the following problem. Find an equation of the tangent line, okay, to the curve y equals 1 plus x cosine x at the point when x equals 0, y equals 1. Okay. It's hard to draw the graph. It's hard to draw the graph, and we're not going to draw the graph. All you have to do, how do you express clearly, right? You need to say that the slope and at that point should be evaluated using this derivative. Okay, we already explained to you why the slope of the tangent line should be equal to the derivative function. Then you find the derivative. Okay, you apply the product rule. So it's 1 plus x prime cosine x, 1 plus x cosine x prime. So I get 1, so cosine x, and this should be negative 1 plus x sine x. Okay, so that's the first step. Then you evaluate at the 0. So you get cosine 0 minus 1 plus 0 sine 0. And that is going to be 1. Okay, so this is the slope of the tangent line. Then the equation is going to be y minus 1 equals 1 times x minus 0. Now, there do have some students totally forgot to evaluate the function. And then you write down the equation. Here, this is a slope because the slope is cosine x, and you gave me the answer like that. Okay, that would be wrong. And this is a mistake, a very serious mistake. Number 1, you don't know the equation of a tangent line should be a linear equation. And then you got a nonlinear equation. It's not a linear equation. And you did not even realize that. That's wrong. So this is not a linear equation, right? That's why it's wrong. I just trying to explain it. So when you get an answer, look at the answer. Is it reasonable, right? Sometimes, yeah, if you look at this equation, this is not a linear equation. It's a sine function, cosine function, right? So this cannot be equation of a line. Then you have to go back. What's wrong with that, right? Because you forgot to evaluate the derivative at x equals 0. Okay. So you have to make sense. Sometimes you like to find the temperature of some object, you end up with like a 2,000 degree level. That's clearly wrong. You have to go back to look at it. You cannot just tell you the quiz. Okay? So this is use of common sense. Yeah. All right. Let me stop here. Okay, we're going to have a quiz next time.